Video 34, dividing fractions.
Dividing fractions. We've talked about this symbol here, meaning that we were going to put things into groups. We were grouping amounts. So here I've got 3 divided by 1/3 is the same as. So I'm going to draw it out for you. I've got 3 holes. Whoops. And what I need to do with these 3 holes is I need to group them into thirds. So that's 1/3, oh, really dodgy, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3 and 9/3. So 3 holes divided by 1/3 is the same as 9. If I was to put this into context for you, and because Mr. Slade's obsessed with Merv, we could say initially that each one of these holes was a packet of crisps, cheese crisps. And Merv was going to have a party, and each bowl that he filled up with crisp would hold up 1/3 of a packet. How many bowls would he need? So that would be 1 bowl, 2 bowls, 3 bowls, 4 bowls, 5 bowls, 6 bowls, 7 bowls, 8 bowls. So you've got a bit of an understanding of what division with fractions actually means. Let's look at this one. So this is 3/4 divided by 1/4. It's really simple to draw it out when we've got the same denominator. So I'm going to draw out my quarters, and I'm looking at 3 of them. So that's my fraction I've got. How many groups of 1/4 can I get from that? 1, 2, 3. So my answer is, so let's put it into a word problem. This is my very rectangular pizza. I've eaten 1 piece and I'm left with 3/4. I'm going to put that in the fridge. The next day my friends come round and I'm only still going to serve it in 1/4 slices. So how many of my friends will get a piece of pizza? That would be 3 of them.
Okay, now you've seen the visual representations of it, let me show you the calculation that you can do to quickly and easily work these out. Let's start up here. So we have 3 divided by 1/3. Now, as William said, that is basically we have 3 sections and we're cutting them into thirds. Now this is a little bit weird and it does look like a bit of a trick, but actually because we know division and multiplication are linked together, we can use multiplication to work out our division. But what we have to do is link it to the inverse. We know division is the opposite of multiplication, so actually I'm going to swap these around. So instead of saying it's 1/3, I'm going to put a line through that and have it as 3 1s. And now, because I've swapped that, I need to do the inverse of it. So now I need to do 3, and if you remember from our previous video, 3 holes is actually 3/1 as well. So 3 times 3 equals 9, because we multiply our numerators together, and we multiply our denominators together, which is 1 times 1, which equals 1. 1/9, we know, is the same as 9 holes. Right, moving on to here. Similar idea. This time we don't have to change anything with this because it's not a whole number. But here we have 1/4. I'm going to inverse it. So it's 4/1. And then I'm going to have to change to the inverse there. So now, I'm just going to do that. 3 times 4 equals, let's just move my 3. I'm going to put it up there just so you remember that actually that's the answer. But 3 times 4 equals 12. And then 4 times 1 equals 4. And 4/12 as an improper fraction, how many times does 4 go into 12? Well, it goes in 3 times. So here is my original answer. What is useful for this method, it means that we can even work out the other way round. So we have a third divided by 3, which will give us a different answer. So here we go. Same way as I go before. First thing I've got to do is make that into 3 over 1, because we know that's what we always do, because that's what it is as a fraction. But then I have to inverse it. So turn it to 1 over 3. Ooh, getting a little bit stuck. And then that means I have to inverse my multiplication. So 1 multiplied by 1 equals 1. 3 multiplied by 3 equals 9. So actually 1/3 divided by 3 equals a 9th. If we think about that in a visual way, that means I have 1/3, and I'm actually dividing that into 3 separate sections. But because I can't have these as all separate things, I have to cut it all into equal parts. So now I have 9 parts, and I'm only looking at one of them, so it would be 1, 9.
Okay, have a look at the examples. Again, have a go at them. Pause the video and we'll go through the answers in a second. So we're going to go for this first one here. 4 divided by 2/3. So as I stated before, 4 wholes is just the same as 4 firsts. So as we were saying, when it comes to division, the easiest way, if we're not going to draw it out, the easiest thing for us to do is to use our inverse understanding. So the opposite of division is multiplication, and therefore we're going to have to swap the numerators and the denominators over. So here we're going to swap this fraction as 3 halves. So we're going to get rid of that one too. Now we're going to follow our multiplication of fractions strategy. We're going to go 4 times 3, which is the same as 12 for our numerator, and 1 times 2, which is the same as 2. Okay, this is our improper fraction as well. We're saying, what is that as a mixed number fraction? We know that 2 goes into 12 6 times. So the answer would be 6. Let's look over at our beautiful 3-star question. Gorgeous stars there as well, Mr. Slay. So I'm just going to give myself a bit more space over here. Can we still see that?
Yep.
Excellent. So, again, the easiest strategy is to use our inverse understanding. We're going to turn our division into a multiplication, and that means we need to swap over our numerator and our denominator. So the 6 denominator goes into our numerator, and our 3 numerators need to go into our denominator, giving us now the calculation 2/5 times 6/3. So 2 times 6 is 12, and 5 times 3 is 15. That is a normal fraction. We haven't got a numerator bigger than the denominator, and actually I can see that a common factor of both of those would be 3. So I could simplify this further. Divide 12 by 3, divide 15 by 3. Whoops. 12 divided by 3 is 4, 15 divided by 3 is 5. So at its simplest form, 2/5 divided by 3/6 is the same as 4/5. Okay, so we're going to put our dividing fractions onto our number mind map. So we're going to go up here in our mind map. I'm going to put here dividing fractions. Do you remember we were going to put things into groups when we're dividing? But actually we realised that it was a lot easier. We understand what we're doing when we're dividing fractions. But all we do, I'm going to choose a different colour here, is we're going to do the inverse of division and swap our numerators and denominators around and times along accordingly. So where does that fit in? It fits in perfectly with multiplication of fractions. I just don't quite know how I'm going to get there. So, let's see how this pans out. Let's go up here. Oh, this is such a mess. Ah. Okay. And along that line, I'm also going to draw a green inverse line, because we truly know that division is the multiplication of, division is the inverse of multiplication when we're looking at multiplying and dividing fractions. We also were using our times table understanding, which again is all the way down there. So I'm going to come round. Oh no. Sorry, I know that's a bit quick for the camera. And we'll go in that way there as well. And we also had our division understanding when we were drawing it out. And when I come from here, I think I've massacred our, oh dear, that was horrendous, into there.